So I came through a route with a degree in pharmacology of all things, so nothing to do with any of the computing or data analysis. And then I've learned all the other stuff as I've come along on the way, which is quite typical from a lot of people that do work in the field. But these days, there are courses where you can go and train specifically and know that that's the direction you're going in. Bioinformatics has become much more of a focused field. I think I was quite early into it. There weren't these clearly defined routes. These days, you can go in via the NHS. They have specialist training pathways where they'll take people, I believe, after a degree and then provide you with the specific bioinformatics required for the clinical services. Within sort of more of the university, the research side, we offer master's courses, and then there are particular PhDs that would sort of develop your skill set in particular areas. Most of the people that I rate in the profession may not have actually been taught all the different elements. They're very self-motivated. They're about solving problems, solving solutions and things like that. So I think it's more of an aptitude towards dealing with the data rather than being told what to do. Say I trained in pharmacology, and after nearly a year in the lab, I decided that lab work just wasn't for me. It took too long to actually get to something that sort of an output, and by then I just wasn't interested anymore. I'd always been good at computing and have played with that on the side. So it was just bringing together the science, which I enjoyed, the computing, which I enjoyed, and sort of following those opportunities that were presenting. No day's the same. There's always opportunities to learn new things, jump on new challenges. You're always being challenged. Data is everywhere. Everybody in science now needs data. And unfortunately, data is often thought of as, and sort of analysis as just something that you press a button. I think people underestimate the time it takes. So there's always that pressure to get things done, lots of things, and do them quickly. I think it's knowing that there are these sort of little pockets of professions out there that, you start off thinking you're going to go into an area of biological science. Maybe you're interested in genetics, maybe you're interested in forensic science. And then you discover within it, there are these little specialities. And I think keeping an eye out for the things that you're good at and you enjoy within a field sometimes gives you that little niche rather than going for the headline job title. I think it's just the fact that if you like biology and you like computers, there's things you can do out there. You don't necessarily have to do one. One of the dilemmas I had in life was, well, I was quite good at computing. Computing is a way of earning lots of money if I was to go and do banking or something like that. But there was never the drive there for me to do it. So I think it's that thing of, if you follow the things you enjoy doing, you'll find some niche. Clearly, I would have got more money if I'd gone into banking, but life's regrets. Embrace the things that you enjoy, even if they're not necessarily easy. As I say, I always had that love of computing, and that meant doing things in after-school clubs and lunch times to learn that thing that didn't necessarily fit within the curriculum. I think the other thing to learn is, do take the advice of those around you, but they're not always right. So for instance, my science teacher when I was 15 told me I had no aptitude for science and that I'd be lucky if I was to scrape sort of a low-level grade. And here I am now. So do take advice on board, but people giving it to you aren't always right. I could talk about getting grants in and papers, which are the things that people within the science field rate as the things. I think the fact that I'm still doing it, I've been doing this for 20 years now, and I'm still being challenged every day and doing something I love. So you can ask for nothing more from a career. This afternoon, I've been discussing some work I've been doing with somebody down in Swansea, where we're looking at using machine learning approaches in prostate cancer. We're trying to save patients an invasive procedure by looking at some way of taking various markers in blood and use those computational methods to come up with something that gives you a better outcome and is going to be better for the patient. So that's the sort of thing that really gets you up out of bed in the morning and wanted to make that impact.